Good morning, third year, and welcome back for a new week of physics at home. Now, over the weekend, you had homework to read the assignment posted on Firefly, which was about Ohm's law, and use the marking scheme and candidate guide, as well as the video I posted where I talked about how you mark an assignment to see what you think the assignment should be worth. If you've done that task, you will be more well prepared for this week's classwork, which is yourself going to carry out an experiment at home and write it up in the style of a National 5 assignment. So, because we're at home, we don't have a lot of equipment. An easy experiment I think we should all be able to do is going to look at dropping a ball and measuring how high it bounces, its rebound height. So all you need is a ball, football, tennis ball, golf ball, table tennis ball. As long as it's round and bounces, it will do the trick. And a ruler. If you don't have a ruler, you could ask your parents for a measuring tape. Usually these are found lying about in the garage, or there's almost a drawer in your house where you keep these sort of things. Now, what you're going to do is take the ball and drop it. Use your ruler and mark how high it rebounds. Very simple, straightforward experiment. You're going to increase the height which you drop the ball from, and every time you do so, record the height it bounces. Now, in the past, pupils have used their phones because of the slow motion camera to film what happens to show them more accurately where the ball bounces to. You may want to stick the ruler to the wall with blue tack or sellotape. You may want to do it outside and mark on the wall 10 centimeters, 20, 25, 30. It is up to you how you do so. So our little diagram here shows us how we would carry out the experiment. The drop height is measured, the ball hits the ground and bounces back. Where it bounces back to is the height you are interested in for your results. We're going to complete a table of results. If we use a drop height of 20 centimeters, 40 centimeters, 60 centimeters, 80 centimeters, and 100 centimeters, make sure you have units. You can then record how high it rebounds and work out an average. You will need 3 sets of data for each drop height. However, I don't imagine this experiment taking you longer than 10 minutes. Once you have your data, you're going to use the candidate guide, all of the information found in last week's videos and also shared on last week's Firefly posts. These are all Word or PDF documents you can open. So you must come up with a title for this experiment. This doesn't have to be something ingenious. You could simply call it the bouncing ball experiment. You must come up with a name. What are we trying to investigate? What is it that we're actually looking at in terms of our results? This is the part that is going to be tricky. I want you to use your knowledge of physics to explain to me what happens to the ball. Does the bouncing ball rebound higher, the same, or less height? Does it depend on how high you drop it from? Are your results consistent? You will have to use a textbook, school notes, BBC Bitesize, YouTube, and the internet, any source you can find to help you phrase what you know. Now, this section is worth 3 marks, which is one of the highest marks you can get for any section in the assignment, so it is the one that requires the most detail. You must give a description of the experiment. This is just a brief paragraph. It does not have to be very, very detailed, just tell us what you did. You must include a table. Now, I've already put a table in here for you, and I've added in some units. There is some units left for you to add in. Some of you may be able to print this out, that's great. If you can't print it out, you can copy it into a jotter, or you can even fill it in on the Microsoft Word, it's up to you. You would take your table and turn it into a graph. Now, if you think of a graph, and this goes back to first year, you need to think about what goes on each axis. On our x-axis, the horizontal axis, you want the independent variable. And on the y-axis, you would like the dependent variable. So what did you change? What is the independent variable? I'll give you this one. That is the drop height. So that will be on your x-axis. Now, you put the plot onto the graph and you fit a line as best as you can. This could be a curve or a straight line. That will be for you to find out. Any internet source or book you use, you should write down its name and you should give its full reference. The reference and how to do so is also found in the candidate guide and the marking instructions, which was all posted last week on 2 occasions. You should analyse the experiment. Do your results match what you thought you would get? Are they similar to what the internet source you use finds? A conclusion. So, what did your experiment prove? Did you match your aim? Did it do what you thought it would? Just a sentence or two to explain so, and an evaluation. Was your experiment accurate? Is dropping a ball and marking on the wall with chalk accurate? Is there any things that could affect your results? You must try and come up with at least 1 or 2 evaluation points. Now, this is not going to be something you do in 1 hour. It will take you the 3 periods of the week to complete. So do not rush and do not panic about having all this to do today. I've added in some graph paper here for your graph, and feel free to print that out again, or you could use a ruler, or if you're really struggling, sketch the graph into your jotter. This is something that you won't get in the actual exam, the actual assignment, but because this is a mock assignment and your first attempt, I'm going to give you some areas from National 5 to look at to help you. Now, you may remember we studied energy and potential energy, and there's a lot of questions about things that are falling. We also looked at kinetic energy, objects. Kinetic energy, how is that affected? What are the formulas for both? Potential energy, mass times gravity times height, kinetic, a half mv squared. How do these tie into the bouncing ball? Work done, energy that is lost due to air resistance, also important. And then some S2, S1 physics, speed, distance, time. Are these affected by the height of the ball being dropped? And also gravity, the acceleration due to gravity. Studying these areas to help you write your underlying physics should be enough for this mock assignment. You have the school notes which detail information about all of these. A textbook will talk about these, Bite Size talks about these, plenty of useful sources out there. So, hopefully you can get outside in the sunshine today, as it looks like it's going to rain the rest of the week, to get your initial results taken down. You need a ball and a ruler. I will be on Teams during the periods that you're meant to be in physics, if possible, to answer any questions you have about how to do this. I'm just going to jump onto Teams right now to discuss last week's homework. So keep an eye on Firefly. I'll direct you to the page where all of this information will be stored. You can watch the video as many times as you like, and you can go back to last week's tasks for all the documents that are going to help. Thanks.